Ever wondered why some developers breeze through technical interviews while others struggle with basic logic? It almost always comes down to one thing: a rock-solid understanding of data structures. In this video, we will cover Data Structures Interview Preparation Questions and Answers Mastery course. Master your next technical interview with this comprehensive guide to data structures. In this video, we are diving into 30 high-impact multiple-choice questions designed to simulate real-world technical interviews and certification exams. We cover everything from fundamental arrays to complex graph theory. Make sure you have a pen and paper ready to track your score. And stay until the end for the detailed breakdowns. What is the time complexity of searching for an element in a balanced binary search tree, BST? Option A, O, 1. Option B, O, n. Option C, O, log n. Option D, O, n log n. The correct answer is C. In a balanced binary search tree, the height of the tree is logarithmic relative to the number of nodes. Log n. During a search operation, we eliminate half of the remaining nodes at each step by comparing the target value with the current node's value. This divide and conquer approach results in a time complexity of O log n. If the tree were skewed, unbalanced, the complexity could degrade to O n. Which data structure is best suited for implementing a undo feature in a text editor? Option A, queue. Option B, stack. Option C, linked list. Option D, array. The correct answer is B. The undo feature follows the last in, first out, LIFO principle. The most recent action performed is the first one to be reversed. A stack naturally supports this behavior with its push and pop operations. When a user performs an action, it is pushed onto the stack. When they click undo, the top element is popped and reversed. In a doubly linked list, what is the minimum number of pointer changes required to delete a middle node? Option A, 1. Option B, 2. Option C, 3. Option D, 4. The correct answer is B. To delete a middle node in a doubly linked list, you need to update the next pointer of the previous node and the previous pointer of the next node. Specifically, the previous node's next pointer must now point to the deleted node's successor, and the successor's previous pointer must now point to the deleted node's predecessor. This involves two primary pointer reassignments. What is the maximum number of nodes in a binary tree of height k, where the root is at height 0? Option A, 2 k1. Option B, 2 k plus 1, 1. Option C, 2 k. Option D, 2k. The correct answer is B. A binary tree has one node at height 0, 2 nodes at height 1, 4 nodes at height 2, and so on. This is a geometric progression. 2 to the power of 0 plus 2 to the power of 1 plus 2 k. The sum of this series is 2 k plus 1, 1. For example, a tree of height 2 can have a maximum of 2 plus 1. 1 equals 7 nodes. Which of the following is a technique used to resolve collisions in a hash table by storing all elements that hash to the same slot in a list? Option A, open addressing. Option B, linear probing. Option C, chaining. Option D, double hashing. The correct answer is C. Chaining, or separate chaining, involves maintaining a linked list, or another data structure, for each bucket in the hash table. When multiple keys hash to the same index, they are simply appended to the list at that index. This contrasts with open addressing, where the algorithm searches for the next available empty slot in the array itself. Which of the following notations is also known as reverse Polish notation? Option A, infix. Option B, prefix. Option C, postfix. Option D, none of the above. The correct answer is C. Postfix notation is called reverse Polish notation, RPN. In this notation, operators follow their operands, e.g., 3-4+. It is highly efficient for computer evaluation using a stack because it eliminates the need for parentheses and follows a strict order of operations based on position. What is the primary disadvantage of a basic linear queue implemented using an array? Option A, slow access time. Option B, difficulty in deletion. Option C, wastage of space. Cannot reuse vacated slots. Option D, complexity in implementation. The correct answer is C. In a linear queue using an array, once elements are dequeued, the front pointer moves forward. The spaces before the front pointer become empty, but they cannot be reused for new elements even if the rear pointer reaches the end of the array. This leads to false overflow. This issue is typically solved using a circular queue. Which algorithm is most efficient for finding the shortest path from a single source to all other vertices in a graph with non-negative edge weights? Option A, Bellman-Ford. Option B, Dijkstra's algorithm. Option C, Floyd-Warshall. Option D, Prim's algorithm. The correct answer is B. Dijkstra's algorithm is the standard choice for single-source shortest paths when edge weights are non-negative, typically running in O(E) log v time with a priority queue. Bellman-Ford can handle negative weights but is slower. O(V). Floyd-Warshall is for all pairs shortest paths, and Prim's is for minimum spanning trees, not shortest paths. In a preorder traversal of a binary tree, in what order is the root node visited? Option A, first. Option B, in the middle. Option C, last. Option D, depends on the height. The correct answer is A. The preorder traversal sequence is root to left subtree to right subtree. Therefore, the root node is always the very first node visited in the entire process. In contrast, in order is left to root to right, and postorder is left to right to root. What is the time complexity of accessing an element at a specific index in an array? Option A, O(1). Option B, O log n. Option C, O(n). Option D, O(n squared). The correct answer is A. Arrays provide random access. Since elements are stored in contiguous memory locations, the address of any element can be calculated using a simple formula. Base address plus index asterisk size of element. This calculation happens in constant time, O(1), regardless of the array size. In a max heap, where is the largest element always located? Option A, at a leaf node. Option B, at the root node. Option C, in the middle level. Option D, at the leftmost child. The correct answer is B. By definition, a max heap is a complete binary tree where every parent node has a value greater than or equal to its children. This property ensures that the maximum value in the entire structure is always at the root. This allows for 1. Retrieval of the maximum element. Which data structure is typically used to implement breadth-first search, BFS? Option A, stack. Option B, queue. Option C, priority queue. Option D, tree. The correct answer is B. BFS explores nodes level by level to ensure that nodes are visited in the order they were discovered. A queue, FIFO, is used when a node is visited. All its unvisited neighbors are added to the back of the queue to be processed after the current level is finished. Which data structure is typically used to implement depth-first search, DFS? Option A, queue. Option B, stack. Option C, heap. Option D, array. The correct answer is B. DFS explores as far as possible along each branch before backtracking. This last discovered, first explored behavior is perfectly handled by a stack. LIFO. DFS can also be implemented using recursion, which internally uses the call stack. Which sorting algorithm has the best worst-case time complexity? Option A, bubble sort. Option B, quick sort. Option C, merge sort. Option D, selection sort. The correct answer is C. Merge sort has a worst-case time complexity of n log n, because it consistently divides the array in half and performs a linear merge. Bubble sort and selection sort are n squared. Quick sort, while fast on average, has a worst case of n squared when the pivot selection is poor, though this is mitigated by randomized pivots. Which of the following is a key advantage of a linked list over an array? Option A, faster random access. Option B, lower memory overhead per element. Option C, dynamic size and ease of insertion, deletion. Option D, better cache locality. The correct answer is C. Linked lists are dynamic. They can grow and shrink at runtime without needing to reallocate or copy the entire structure. Inserting or deleting a node only requires updating pointers. 1. If the position is known, whereas arrays require shifting elements. N. What is load factor in a hash table? Option A, the time taken to hash a key. Option B, the ratio of number of elements to the size of the table. Option C, the number of collisions per second. Option D, the size of the hash function code. The correct answer is B. Load factor, lambda, is defined as n per meter, where n is the number of stored entries and m is the number of slots. Buckets. It indicates how full the hash table is. A high load factor increases the probability of collisions and slows down performance, often triggering a rehash to a larger table. A binary search tree is generated by inserting the following integers in order: 50, 30, 20, 40, 70, 60, 80. What is the in-order traversal of this tree? Option A, 50, 30, 20, 40, 70, 60, 80. Option B, 20, 30, 40, 50, 60, 70, 80. Option C, 80, 70, 60, 50, 40, 30, 20. Option D, 20, 40, 30, 60, 80, 70, 50. The correct answer is B. A fundamental property of a binary search tree, BST, is that its in-order traversal, left root right, always produces the elements in sorted ascending order, regardless of the insertion order. As long as it forms a valid BST, the in-order traversal of these numbers will be the sorted list. 20, 30, 40, 50, 60, 70, 80. In a circular queue implemented with an array of size n, what is the condition for the queue being full? Option A, rear equals n1. Option B, front equals rear plus 1. Option C, rear plus 1. %n equals front. Option D, front equals rear plus 1. %n. The correct answer is C. In a circular queue, we use the modulo operator to wrap the pointers around. The queue is considered full when the next position after the rear, calculated as rear plus 1 %n, is equal to the front. This condition leaves one empty slot in the array to distinguish between a full queue and an empty queue, where front equals rear. What is the space complexity of a 2D array with dimensions mxn? Option A, O, m plus n. Option B, O, m asterisk n. Option C, O, log, m asterisk n. Option D, O, 1. The correct answer is B. A 2D array is a grid of elements. The total number of memory cells required is the product of the number of rows, m, and the number of columns, n. Therefore, the space complexity is proportional to the total number of elements, which is O, m asterisk n. Which of the following is true for a complete binary tree? Option A, every node must have exactly 2 children. Option B, all levels are completely filled except possibly the last level, which is filled from left to right. Option C, the tree must be perfectly balanced. Option D, the root must have a value greater than all its children. The correct answer is B. A complete binary tree is a specific type of binary tree where every level, except possibly the last, is completely filled, and all nodes in the last level are as far left as possible. This property is crucial for efficiently representing trees in arrays, such as in heaps. If an algorithm's time complexity is O, n squared, how much longer will it take if the input size n is doubled? Option A, 2 times longer. Option B, 4 times longer. Option C, 8 times longer. Option D, logarithmic increase. The correct answer is B. In O, n squared, complexity, the execution time is proportional to the square of the input size. If you replace n with 2n, the new time becomes 2n squared equals 4n squared. This means the time taken increases by a factor of 4. What is the time complexity to reverse a singly linked list with n nodes? Option A, O, 1. Option B, O, log n. Option C, O, n. Option D, O, n squared. The correct answer is C. To reverse a singly linked list, you must visit every node exactly once to change its next pointer to point to its predecessor. Since you perform a constant amount of work for each of the n nodes, the total time complexity is linear. O(n). What happens when you try to pop from an empty stack? Option A, overflow. Option B, underflow. Option C, garbage collection. Option D, nothing happens. The correct answer is B. In data structures, underflow refers to the condition where you attempt to remove or access an element from an empty structure. Overflow is the opposite, attempting to add an element to a structure that has reached its maximum capacity. In open addressing, which probing method suffers most from primary clustering? Option A, quadratic probing. Option B, double hashing. Option C, linear probing. Option D, separate chaining. The correct answer is C. Linear probing checks the next immediate slot, index +1. When a collision occurs, this tends to create long runs of occupied slots, known as primary clusters. These clusters increase search time because any key hashing to any slot in the cluster will have to probe through the entire cluster to find an empty spot. What is the maximum number of edges in a simple undirected graph with v vertices? Option A, v squared. Option B, v1. Option C, v1, 2. Option D, 2 volts. The correct answer is C. In a complete undirected graph, every vertex is connected to every other vertex. Each of the v vertices can have an edge to the other. v1 vertices. This gives v1. However, since the graph is undirected, the edge between A and B is the same as B and A. Therefore, we divide by 2 to get v1, 2. Which of the following tree traversals is required to construct a unique binary tree? Option A, only in order. Option B, preorder and postorder. Option C, in order and either preorder or postorder. Option D, only preorder. The correct answer is C. To uniquely reconstruct a binary tree, you need the in-order traversal plus one other traversal, either preorder or postorder. The preorder-postorder identifies the root, while the in-order allows you to distinguish which nodes belong to the left and right subtrees. What is the time complexity of building a heap from an unsorted array of n elements? Option A, O(1). Option B, O(n). Option C, O(n log n). Option D, O(n squared). The correct answer is B. While inserting n elements one by one into a heap takes O(n log n), the build heap algorithm, using bottom-up heapify, runs in O(n). This is because most nodes are near the leaves and require very few swaps, while only the root requires O log n swaps. The mathematical summation of the work per level converges to O(n). Which sorting algorithm is often used when the range of input values k is not significantly larger than the number of elements n? Option A, counting sort. Option B, quick sort. Option C, heap sort. Option D, shell sort. The correct answer is A. Counting sort is a non-comparison-based sorting algorithm that works in O(n plus k) time. It counts the occurrences of each unique value. It is extremely efficient when the range of possible values, k, is small, but it requires extra space proportional to that range. An adjacency matrix is a better choice than an adjacency list for which type of graph? Option A, sparse graph. Option B, dense graph. Option C, disconnected graph. Option D, tree. The correct answer is B. In a dense graph, where the number of edges is close to v squared, an adjacency matrix is efficient because it takes O(1) time to check if an edge exists between two vertices. In contrast, for sparse graphs, few edges, an adjacency list is preferred because it saves significant memory. Which type of linked list does not have a null pointer at the end of the list? Option A, singly linked list. Option B, doubly linked list. Option C, circular linked list. Option D, header linked list. The correct answer is C. In a circular linked list, the next pointer of the last node points back to the first node. The head of the list. This creates a continuous loop, meaning no node in the list points to null. This is useful for applications like round-robin scheduling. That wraps up our 30-question deep dive into data structures. How did you do? Whether you got a perfect score or found some areas to improve. Remember that consistency is key in mastering DSA. If you found this video helpful, please give it a thumbs up and subscribe for more technical interview prep. Don't forget to comment your score below. For a comprehensive practice experience with even more questions, check out the full course link in the description below.